All right, let's move on to our next section of chapter 8. We're going to talk about set operations and compound inequalities. So we're going to see compound inequalities here, and then we're going to see them again when we're talking about absolute value. So that'll be a little bit later in chapter 8. But let's go ahead and start talking about set operations first, because we're going to need these for our compound inequalities. All right, so we have a couple of set operations. Just to go over some definitions here, this big U, and there's no kind of tail on this U, it's just a big U means union. An upside down U means intersection. And then a 0 or an O with a slash through it, we saw a little bit already. This is the empty set. So that's literally just a set with nothing in it. It's an empty set. So the way you can remember these, the U for union, normally that's the easy one to remember. So then you know that this upside down U has to be intersection. Let's go ahead and look at some examples here where we find the union and intersection of some sets. So for A equals 3, 4, 5, and 6. We don't write the and in there. We're just going to write the numbers listed out, normally from least to greatest. And B equals 5, 6, 7. Find, see, number 1, let's go ahead and find A intersect B. Now, for intersection, you want to think of kind of the overlap between the two sets. It's where they intersect. So if we look at our two sets, we have 3, 4, 5, and 6. And then in the other set, we have 5, 6, and 7. So where's the overlap? What do they have in common? Well, they both have a 5, and they both have a 6. The other numbers they don't have in common, this has a 3 and a 4, this one has a 7. So the overlap here is 5 and 6, and so our intersection is still a set, and it's going to be the set of the numbers 5 and 6. So that's all we're doing here for these intersections is writing down what they have in common. Now for the union, so A union B, when you think of union, think of two things joining together. So if I were to join these two sets together, we would have the set 3, 4, 5, 6, and 5, 6, and 7. But we do not want to write any numbers twice. So since we have two 5s, I'll just get rid of one of them, and we have two 6s. So the union is everything that they both have in common from the smallest number to the largest number. So the union here is 3, 4, 5, 6, and 7. So let's write this over here. 3, 4, 5, 6, 7. So think union, joining together, intersection is the overlap. Okay, let's try one more here. What if we had A intersect the empty set? Well, remember, A is the set 3, 4, 5, and 6. And if we want to intersect that with the empty set, well, the empty set is literally a set, so these curly brackets here, with nothing in there. So what do these two sets have in common? They have nothing in common, which means the intersection of these two would be the empty set. Okay, so now let's go ahead and look at one more example here. This one's going to be for two different sets. So for R equals 1, 3, 5, and S, which is 2, 4, and 6. We're going to go ahead and find R intersect S, and we're also going to find R union S. So now that we've done that first one together, I would go ahead and pause and try this one. This one, just be a little bit more careful with the intersection. Remember, we're looking for the overlap for the intersection and then everything that's included for the union. So if we go ahead and look at the intersection, we have a 1, 3, and 5, and a 2, 4, and 6. So what do they have in common? Well, they don't have any numbers in common at all. This one has a 1, this one does not. This has a 3, S does not, and R has a 5, S does not. Same thing with the numbers in S. They're not included in R. So our intersection is empty, which means we're going to put the empty set. And now if we take a look at the union is every single number that's included in both of these sets. So we have 1, 3, and 5, and 2, 4, and 6. So all I'm going to do is I'm going to take these numbers and write them in numerical order. So we have 1, 2, 3, 4, 5, and 6. Now, it wouldn't be wrong if you wrote them in the order that we had them in, so 1, 3, 5, 2, 4, 6, unless my math lab specifies and says write it in numerical order. All right, so now we're going to take a look at compound inequalities, which is going to take what we just learned right here, thinking of the intersection as the overlap and the union as everything that's included from the least to the greatest. Let's take a look at compound inequalities with the word and before. So get a new page here. So compound inequalities with the word and. So we're going to see two different types. We're going to see the type with the word and some with the word or. Now, those two types of inequalities just represent intersections and unions. So if we take the example x plus 1 is less than or equal to 9, and x minus 2 is greater than or equal to 3. This is saying whatever solution we get has to satisfy this first inequality and the second inequality. So it has to satisfy both, which if we think back to our intersections over here, this is exactly what an intersection is. It's the set of numbers that satisfies both or that go into both of these sets. So this just means that we are looking for the intersection. And it's going to look a little different because we're looking at inequalities. So it's not going to be a set of numbers unless you're looking at interval notation, which we will do. We're also going to be looking at the graph because that's the way that I find is the easiest to find these intersections. So first step is we're going to solve each inequality separately. So we're going to go through, if we were looking at this one up here, I would subtract the 1 and then add the 2 on this one. Go through our normal steps for solving. And then second, we're going to graph on number lines. And so you can graph them on 2 number lines or 1. I'm going to show you both ways. But the important thing is here is that the scale of your number lines have to line up. So I'll put make sure the number lines line up. And so we'll see what that looks like in an example. You can always just put them on one number line too. You just have to be kind of careful doing it that way so that you don't cover one of the graphs up. And then lastly, we're going to write the intersection in interval notation. We're always doing interval notation when we have inequalities. Now, what I mean by intersection here, kind of like when we had our sets of numbers over here, we thought of this as the overlap between the two. We're also going to think of our intersection on the graphs as the overlap. So we're going to find the overlap, which is why it's easiest to kind of line up the graphs so that all the numbers, the tick marks on the graphs kind of line up. Okay, let's go ahead and look at a few examples. So we're going to find the solution set. As a graph and interval notation. So sometimes you'll just be finding the solution set, which just means the interval notation. Sometimes they'll also want you to give the graph, which is most of the time. We're going to be doing that on all of these anyway. So this first one here, we're given x is less than 10 and x is greater than 2. So we want to find some number or some set of numbers that is less than 10 and greater than 2. So first thing I'm going to do, since they're both already solved, they have x's by themselves, I'm going to go ahead and graph them. So I'm going to set up a number line. And now what you want to do is you can either do it on one number line, and I'm going to show you guys both. So we'll do one number line over here, two number lines over here. But what I'll normally do is put the two numbers on, make sure they're in order, so 2 and then 10. And if you want to do more than just these two numbers, you can. Sometimes they'll be close together, like if it were 2 and 5, I might fill in the numbers in between. These ones are going to have quite a few numbers in between. So I'm just going to leave it as 2 and 10. And notice how on the right here, when we have two number lines, I'm lining up the 2 and the 10. That's the key thing here. So let's go ahead and start graphing. So I am going to, let's use red for this guy, for x is less than 10. You can just do this in one color. I just want to make sure you guys see which one is which. So remember, for less than, we're going to use a parenthesis, and we want everything less than 10, so we're shading to the left. So let's put a parenthesis, shade to the left. And let's go ahead and do that on this graph over here on the right. So we're going to parenthesis, shade to the left. And now if we go ahead and do x is greater than 2, x is greater than 2, we're going to have another parenthesis, but this time we're shading to the right because everything greater than 2. So on the single number line, unless you're working with two different colors like I am, I'll normally put it right above the graph and shade to the right. That's the only thing you have to be careful with, because if you're doing this in pencil or pen, it's sometimes hard to see the overlap unless you put it above the graph. So either put it above the graph or do two number lines. And if we go ahead and put this on the second one here, we're going to have a parenthesis, shade to the right. And this is why it's important to line those tick marks up. We want to see where the overlap is. So see how there is overlap, let's get a different color here, between these two sections here. So starting at 2 and going to 10, anything before that, we have red but not green. Anything to the right, we have green but not red. Same thing, you can see it here, we have that overlap. So we want to write that overlap as an interval. And so our interval here, actually, let's go ahead and write our final graph for this one. They're going to have you take two graphs like this on my math app and write the intersection. So if I were to graph the intersection, again, I'll put 2 and 10 right here. The intersection is just that portion of the overlap. So we're starting at 2, and you're going to take whatever bracket or parenthesis you have. So we have a parenthesis at 2. And the overlap stops at 10 with a parenthesis. So it's just the stuff in between. So this is our final graph. So I'll box this one. And so let's put a solution here. And the other part of our solution is the interval notation. Just like we've done before, take it from this graph. We're going to start at 2 with a parenthesis, comma, go all the way to 10 with another parenthesis. All right, so we have both our graph and our interval. Now, this is usually the trickiest part. Actually solving the inequalities shouldn't be too tricky. So let's go ahead and try a couple more of these where we can get some practice with graphing. So number 2, we have x plus 3 is less than or equal to 1. And so we're looking for the intersection. X minus 4 is greater than or equal to negative 12. Now, if we go ahead and solve each one of these first, because the x's aren't already by themselves, let's go ahead and subtract the 3 on the left. So we get x is less than or equal to negative 2. We have 1 done. Now let's go ahead and add the 4 on this one. So we have x is greater than or equal to negative 8. Now we have our 2 inequalities. I'm going to bring down the and. You don't have to do that. We want to go ahead and graph them first. I'm going to stick to 2 number lines. So let's do, I'll do it over here. And if you feel comfortable finding the intersection from your 2 inequalities here, you can. You have to be careful though, because it's not always going to be the space in between them. We'll see one special case like that. Most of the time it will be though. So I'm going to put our 2 numbers on the graph, make sure the smallest one's on the left. So negative 8 on the left, negative 2 on the right. And now let's go ahead and graph. So x is less than or equal to 2. This is a bracket because it's equal to, shading to the left. So bracket, shade to the left. And then for the x is greater than or equal to negative 8, we'll have a bracket. Everything greater than negative 8 goes to the right. And now looking at our graph here, where is our overlap? Well, their overlap is going to be in between these 2 blue lines. So our final graph here, this is kind of like the solution graph that you would be inputting into MyMathLab, is everything from negative 8. And are we going to have a parenthesis or bracket here? Well, we're going to have a bracket because that's what we have at that negative 8. And all the way to negative 2 with another bracket. Shade in between. So this is part of our solution. This is our graph. And then our interval that we get from the graph is everything from the furthest left, so negative 8 with a bracket, comma, the furthest right we go is negative 2 with another bracket. So this is our graph, and this is our interval notation. Okay, let's go ahead and do one more of these. For the most part, they're all going to be really similar where you have that overlap in the middle there. Not always though, so let's go ahead and take a look at this next one. We have 2x minus 3 is greater than or equal to 1, and that's our keyword there. Negative 3x plus 1 is, less than or equal to negative 8. Now let's go ahead and solve both of these. So let's add the 3. So we get 2x is greater than or equal to 4. Then we want to divide by 2. So we get x is greater than or equal to 2. And now if we solve the other one, subtract the 1, we get negative 3x is less than or equal to negative 9. And now remember, when we divide by this negative 3, anytime we divide or multiply by a negative, what do we have to do? We have to flip our inequality. So we get x is greater than or equal to positive 3. Now, if you notice, in all the others, we had a less than and a greater than. That's how we got our shaded regions to go, one going to the left, one going to the right, and we had that kind of overlap in between. This one's going to be a little different because we have a greater than and a greater than. They're going to be shading in the same direction. So let's go ahead and look at the graph. So we have 2 and 3, they're right next to each other, which is nice. Still make sure they line up. Now let's go ahead and graph the x is greater than or equal to 2. So parenthesis or bracket, we're going to use a bracket, and everything greater than 2, we're going to shade to the right. Remember, this points in the direction in which you want to shade, as long as your x is on the left side. So shading to the right. And then x is greater than or equal to 3. Again, we have a bracket, and we're also shading to the right. So bracket at 3, shade to the right. Now, where's our overlap? Well, if we kind of follow along the graph from left to right, the overlap doesn't start until right here at 3, and it goes all the way until positive infinity. The overlap never stops. So we're going to go ahead and combine our two graphs together. So we're going to have 3. And notice how we don't need the 2 because it's not included in the overlap. If you wanted to put more numbers here, you could put like a 4 over here and a 2 over here. You don't need to, you just need the 3. And then at 3, we have a bracket. So we're going to have a bracket, and it's everything shaded to the right. So again, be careful with these. It's not always the stuff in between. Sometimes you won't have any overlap, and in that case, you'd have the empty set. Most of the time, you'll have some kind of overlap because that's why they're giving you these problems. All right, now let's go ahead and write the interval notation. So remember, furthest left is 3 with a bracket, comma, what is the furthest right that we go? Well, the furthest right is positive infinity. Always use parentheses with the infinities. And so this is saying any number from 3, and it can be exactly 3 because it's a bracket, all the way to positive infinity is going to be a solution to both this inequality, so our first one, and our second inequality. That's all it's saying, is it's a solution to both. All right, so those are compound inequalities with the word and. Now let's go ahead and try some with the word or. So I'm going to get a new sheet here so that we can see our instructions as we go. So compound inequality with the word or. This is going to be the only difference between your inequalities. You'll see the exact same thing where you have one inequality on the left, one inequality on the right. The only difference is that it'll be an and or an or. So you have to know the difference. This or is is the same thing as looking for the union. So remember way back here, where is it? There we go. When we were looking for the union, we were looking for everything that was included in both sets. We'll be doing the same thing here where you kind of join the two sets together. You can think about it like the furthest left to the furthest right on the graph. I also like to think of it as you're looking for everything that is shaded. So no longer the overlap. I want everything that's on the graph, or everything that's on both graphs. So now let's go ahead and write out our steps for solving, and then let's take a look at some examples. So let's take a look at our first step. First step is exactly the same. You want to solve each separately, solve each inequality separately. So if the x's aren't already by themselves, you're going to get them by themselves. After you've done that, just like we did before, our next step is going to be to graph. And this one you can do 1 or 2 number lines. I'm just going to stick to doing 2 number lines. So I would just pick a method and stick to it so you're not kind of jumping between 2 different methods. And then you're going to write the solution in interval notation. And remember, a solution for this one is everything that's shaded. So everything shaded. So the furthest left you go to the furthest, furthest left to the furthest right. And that's on both graphs. Okay, so for this next set of examples, we're told to, let's write this differently. Find the solution set as a graph and interval notation, just like we did before. Okay, so number 1, we're given x is greater than 3, or that's our keyword here, x is less than 1. So let's go ahead and look at our graph for this one because they're already both solved. I'm going to start off with 2 number lines and we'll combine it into 1 for our solution set. Just like we did before, I'm going to make sure that the tick marks are lined up. So we have a 1 and a 3. So let's do, oh, that's not a -1. Careful with that one. So 1 on the left, 3 on the right. And so if we graph the x is greater than 3 on the top, we're going to have x is, do this one in red, greater than 3 is everything to the right of 3, and we're going to use a parenthesis. X is less than 1, we're going to have everything to the left of 1 with a parenthesis. Now, because we're looking for the union, we want everything that's on the graph from the furthest left. So that's going to be all the way over here. And to the furthest right. Now you do have to be careful with this one to see how there's kind of a break in between 1 and 3. There's nothing that's shaded here. So we're going to have this left part, this right part, and because it's the union, this means that our solution has to satisfy one or the other, not necessarily both. It might satisfy both, but it doesn't have to. So let's say we picked a number to the left of 1, let's say 0. 0 isn't greater than 3, but 0 is less than 1. So it satisfies one or the other. So you're going to have 2 different parts to our solution here. And so let's go ahead and combine these into 1. Or again, put 1 and 3. So we're going to have everything to the left of 1, everything to the right of 3. And now this is the part that's kind of weird. We want to write this as an interval. So this is our graph. And then for the interval notation, Because we have two different parts here, we have to write two different intervals. So we're going to have the one on the left, we're going to have everything from negative infinity to 1 with a parenthesis. We're also going to have everything from 3 to positive infinity, and I'm going to leave a little space in between, parentheses at both of those, because you don't just want to write two separate inequalities here. We're going to put a union in between. This is the only time you'll actually use one of these symbols when you're looking at inequalities. It joins those two together. It's saying the solution set is the interval over here and the interval over here, or the interval. But make sure you put that U in between. And that's only used when you have two separate intervals. So it's for two intervals that don't overlap at all. All right, so notice the difference between these two types of inequalities. For an and, you're looking for the overlap. For the or, you're looking for everything on the graph that's shaded. So let's go ahead and look at another example here. X plus 2 is greater than 3, or negative 2x is greater than 4. Now, let's go ahead and solve each one of these first. So let's subtract the 2. So we get x is greater than 1. Divide both sides by negative 2 on the right. Now, we're dividing by a negative, so we want to flip our inequality, and we get x is less than negative 2. Those are both solved. Now, if we go ahead and graph these two separately, what numbers are we going to put? Well, we have a negative 2 and a 1, so I'll put negative 2 on the left, 1 on the right. And if we go ahead and graph the x is greater than 1, everything greater than 1 we're shading to the right with a parenthesis. And then x is less than negative 2, we're shading to the left of negative 2 with a parenthesis. And now if we go ahead and look at everything that's shaded, starting from the furthest left, we have everything from negative infinity to negative 2. We jump, take a break until 1, until infinity. Let me actually do those in two different colors so you can kind of see. Oh, shoot. Here we go. So let's go ahead and do this, and let's do this in green, because we have these two different intervals here that we're going to be joining together. So our final graph is going to be everything from, let's put negative 2 and 1 on our number line, everything from negative infinity to negative 2, parenthesis, and everything from 1 to infinity with a parenthesis there. This is our graph. And now for our interval, remember we're going to put everything furthest left to furthest right. So furthest left is negative infinity to negative 2 with a parenthesis. What do we have to put in between? Because we have two separate intervals here, union. And now we're going to have everything from 1 to infinity. So there's our graph, and there's our interval notation. All right, number 3. Let's go ahead and do 2x plus 1 is less than or equal to 9, or 2x plus 3 is less than or equal to 5. Now for this one, let's go ahead and start by solving for x. So we'll subtract the 1. We get 2x is less than or equal to 8. Divide both sides by 2. And we get x is less than or equal to 4. Solving the second inequality, let's subtract 3. We get 2x is less than or equal to 2. Divide both sides by 2. And we get x is less than or equal to 1. Now again, notice for this one that our inequality symbols are both less than or equal to. They were going in different directions for our other ones, so this one's going to look a little different. You're not always going to have two separate pieces for these. So let's go ahead and put our two numbers on the number line. We're going to have 1 and 4. 1 is on the left, 4 is on the right. We've had a 1 in every single one of these. That will not always happen. Okay, so x is less than or equal to 4. So less than means left of 4 with a bracket. X is less than or equal to 1. Less is left with another bracket. Now we're going to start at the furthest left, which is negative infinity. And we want to stop when we don't have any more shading. So remember up top in this example, we went from negative infinity and we went along and we had to stop at -2 because there was no shading on either number line. And then we picked it up again at 1. Now, if we start here, we're going to go along, and when we get to 1, the shading stops on this bottom number line, but I don't care about the overlap. I only care about what is shaded on either one. So the shading continues up top. So we're going to continue along until the shading stops altogether, which is right here at this 4. So always go from left to right. Stop your interval once you have that shading ending. Now, there's no more shading after 4. So we can go ahead and draw our graph. It's going to go from, we'll still have 4 on here. We don't need the 1 though, because see how we don't have to break it up at 1? You can put it on there if you want. But we're going to have everything from negative infinity all the way to 4, and it has a bracket. So these are the weird ones. So these are the ones where you have overlap, but it's not necessary, or sorry, not overlap. You have shading, and for the union, it's not 2 different pieces, it's 1. It's the furthest left you shade to the furthest right. And this one has no breaks. So this is our graph. And again, if you wanted to put some other numbers, you could. And then for our interval, because there's not 2 different pieces, we don't have to use the union. Our furthest left is negative infinity, always use a parenthesis. And what is our furthest right? Well, our furthest right is 4. And we have a bracket. Okay, so that one's one of the tricky ones. Let's go ahead and look at a couple more here. And these last 2 are going to be the special cases. So let's actually, I'm going to make this. So we're going to solve, graph, and write the interval notation. So I'll condense that down a little bit. We're doing the exact same thing. And these are going to be our special cases. So you'll see what I mean by special cases when we take a look at both of these. First one we're going to look at is an and. And so this one we're given x plus 2 is greater than 3, and 2x plus 1 is less than -3. So let's go ahead and look at both of these. So if we solve for x, we're going to subtract 2. We get x is greater than or equal, or sorry, greater than 1. Got another 1 appearing here. Subtract 1 on the other one, so we get 2x is less than -4. Divide both sides by 2, and we get x is less than -2. We weren't dividing by a negative, so we don't have to flip it. Now, we were looking at an and case. And so before you graph, I want you to think, what are we looking for on the graph? Are we looking for everything that's shaded or just the intersection? We're looking for the intersection because it's an and. It has to satisfy both. And remember, that's the overlap. So let's go ahead and graph both of these. So we have this x is greater than 1 and x is less than -2. So let's put 1 and -2 on our number lines. -2 on the left because it's smaller, 1 on the right. Now, x is greater than 1. We're going to have everything to the right of 1, and it's going to be a parenthesis. And everything to the left of -2 because it's less than -2 with a parenthesis. Now, because we're looking at the intersection, if this were an or, so if this were like number 2 up here, we would just have 2 different sections because we want everything that's shaded, regardless of whether it shows up on both. But for an and, we have to find something that satisfies both inequalities, which means we need overlap. We have no overlap. So because there's no overlap, that means that, and this one's kind of weird to graph because there's just going to be nothing on there. We have no solution. So there's nothing on the graph. It's just an empty graph. And so for our interval, we don't really have an interval because our solution set is empty. There is no solution because there's no overlap. So you don't really have a graph for this one. That's one of our special cases. So that's what'll happen if you have no solution with your and case. The other thing that might happen with an or, let's take a look at this one here. So 3x is greater than 6, or -2x is less than -2. Let's go ahead and solve both of these first. So let's divide both sides by 3. We get x is greater than 2, or divide both sides by -2. We're dividing by a negative, so we need to flip our inequality. -2 divided by -2 is 1. So many ones showing up. Okay, now if we go ahead and graph these, and this is not the one that I thought we were doing. Let me change these numbers really fast. This isn't working out. Give me 1 second. All right, let me fix something here. So this first one here was supposed to be a less than. Sorry about that. So 3x is less than 6, x is less than 2. Now this is one of our special cases. Okay, so let's go ahead and draw 2 number lines here. We have a 1 and a 2, 1 on the left, 2 on the right. Now, if we go ahead and graph x is less than 2, less than to the left, and then parentheses, so parentheses, shade to the left. And then x is greater than 1, greater than is to the right, and it's parentheses. Now, this kind of looks like one of our graphs we get when we're looking at an and, but we're not looking at an and, we're looking at an or. So we want everything that's shaded. So if we start at the furthest left here, that we have some shading. If we follow this along, we have shading all the way along here. Even when we get to 2, we still have shading on the bottom graph, and it shades all the way to the right. There isn't any kind of break in shading. Remember, we're looking at either or, not necessarily the overlap. So if we look at our final graph here, we are going to have one because we have shading. We can put 1 and 2 on here, but if we go ahead and look, we had shading all the way from the left to all the way to the right. So our entire number line is shaded. If we pick a number, any number on the number line, it's either going to be a solution to the first inequality or the second. It's just guaranteed. We're always going to have a solution. So this is our final graph, And our interval notation is everything from the furthest left, so negative infinity, all the way to the furthest right, which is positive infinity. So that's our interval notation. So that's our special case for the OR. So those are the two compound inequalities. Now let's look at just a couple of examples that show up on the homework. These aren't, these are more of just kind of understanding unions and intersections. So these examples are just true or false questions. Number one here, we're given the union of negative infinity to 6 with a parenthesis and 6 with a parenthesis to infinity is 6. Now, for these ones, you can kind of think about them or you can draw them out. Let's just kind of talk about this one. So remember, union is everything that's in both of these intervals. So it's everything from negative infinity to 6, union everything from 6 to infinity. So that means everything to the left of 6. So that means like 1, 2, 3, 4, 5. Everything to the right of 6. So like 7, 8, 9, 10. They're saying the solution is just 1 point. It's just the number 6. But 6 isn't even included in either of these intervals here, which means that cannot be the union. So this one is false. Second one here, the intersection of negative infinity to 6 with a bracket and 6 to infinity, 6 has a bracket there too, is the set 6, just the number 6. So remember, we're looking for the overlap because, oh, I wrote that one wrong. The intersection of these two intervals. Now, if we were to look at the graph, and again, you can kind of tell by looking at these intervals, but if we look at the graphs, and put 6 in the middle, we have everything from negative infinity to 6, so that's a bracket, everything to the left, everything from 6 with a bracket to infinity. Now, it doesn't really look like it, that it has an overlap, but see how these both have, let me actually use a different color there. See how they both have a bracket at 6. Because they both have a bracket at 6, that means that 6 is included in both of these intervals and nothing else because they don't overlap anywhere else. So this one is true. 6 is the only thing that they have in common. And let's go ahead and look at our last example here. For this set, we're going to look at one more. The intersection of 4x plus 3 equals 27, 4x plus 3 is greater than 27, and 4x plus 3 is less than 27 is negative infinity to infinity. So let's first think about solving each one of these. If I were to solve this equation here, and notice how they all have the same numbers, just different signs. So I'm just going to switch out the signs. But if I go ahead and subtract 3, we get 4x is equal to 24. Divide both sides by 4, and we get x equals 6. Now, we didn't divide by any negatives, so there wouldn't be any sign flipping. So let's go ahead and just switch out that equal sign for x is greater than 6 and x is less than 6 because they all have the same numbers. They're saying that the intersection or the overlap between x equals 6, x is greater than 6, and x is less than 6 is every single number. Now, if we were looking at the union, that would be true because it's everything less than, greater than, and equal to 6. That's the entire number line. The intersection here, though, is the empty set because this one says x is equal to 6, but 6 is not included in either one of these, which means they can't have an intersection. So this is false. The actual solution is the empty set. So I'll just put that in parentheses because we were just asked true or false. Okay, and then one last little set of examples here. It's a long section, but these ones are fast and kind of similar to what we were just doing. So for these ones, we're told to express in simplest interval form. Now, this is stuff we've already seen. I just want to show you guys so you know what they're asking for. So this first one, we're given the intervals -infinity to 2, bracket, intersect, -4 with a bracket to infinity. Now, if you went to the question help on this one on my math lab, they would go through and have you kind of decide if there's any overlap and stuff like that for this one. What I'm actually going to do is graph these because I find that a little bit easier. I'm going to put our two numbers on, so -4 and 2. And if you don't like graphing, you don't have to do this. You can kind of look at them and see the intersection. This first interval goes from -infinity to 2 with a bracket. The second interval goes from -4 to positive infinity. So that's that whole thing, bracket up -4. And so the intersection tells us to go from, my laptop is slowing down a bunch, that's weird. Intersection is telling us to go from -4 to 2. So in order to simplify this intersection here, we're going to write it as one interval, the interval from -4 with a bracket to 2 with another bracket. So that's all you're going to do, and you'll see examples as well where you have a union. Let's take a look at one of those. So let's say we have -infinity, sorry, I want to box that one, to 10, parenthesis, union, -infinity to 13. So we want everything that's included in both of these intervals because we're looking at the union. So let's go ahead and actually draw out the two number lines. If you can tell what the union's going to be without graphing, that is perfectly fine. But if you want to graph, we're going to have our two numbers, 10 and 13. And let's graph each of these. So everything from -infinity to 10, parenthesis at 10, and then everything from -infinity to 13, parenthesis at 13, and we're looking at the union. So that's the key thing here. If we were looking at the intersection, we'd be looking for the overlap, but the union is everything that's shaded from the furthest left to the furthest right. There's no break in shading, so we're going to go all the way from -infinity to 13. So our interval here is going to be from -infinity to 13. That is the union of these two intervals if we were to combine them into one. So that's the simplest interval form. All right, so that's 8.2. Next, we'll be looking at absolute value equations and inequalities, which are kind of tricky, but then we're going to use our compound inequalities. And then we'll get into a little bit of review in chapter 8, in the last two sections.